Okay, so we're going to play with random numbers a little more. I'm going to write a program that rolls two dice and then adds up the total, and then does that again and again and again and again and again. But remembers how many times it gets each of those totals. How many twos, how many threes, how many fours, five, six. What are all the totals you can get? You roll two dice, you can get the smallest number you can get is two, right? One and a one. And the biggest number you can get is 6 and a 6 or 12. So it's going to keep track of how many times it gets each of those totals, not just total them and print them out, but store them so we can print them out at the end and see which total occurs more often. In order to do that, we need to store a bunch of numbers in some kind of list. We've been using array lists in Java so far because array lists are more like Python lists, which you all already know how to do from 221 from earlier programming. We haven't really talked about arrays in Java yet, so this is another opportunity to do two things at once. Once, play with the random number stuff a little bit more, and second, to see how arrays work in Java. So I start with just declaring my objects that I need in order to read stuff in from the console. So I need a scanner. I'm going to generate random numbers, so I need a random object. And now I'm going to create an array to store my roll totals as I add them up. And that looks like this. Int, and then two square brackets. The square brackets tells Java that we're creating an array. And then the name of the variable, which I'm going to call roll totals. So that's going to, roll totals is going to be an array of how many twos, threes, fours, five, six, up to 12. And then new says I'm going to create a new array. It's going to be an array of integers. And then in brackets, I tell it how big my array is going to be, how many elements it's going to have. How many elements does an array need to have? Well, it needs to have the number of elements for the number of things you need to store in it. But just like lists in Python, you start numbering them at 0. Arrays in Java and almost every language I know start numbering at 0. We can't get any zeros when we roll two dice. We can't even get any ones, right? But I want the index of the array to correspond to the total. So I need to store the numbers 2 to 12. But I'll have the 0 and the 1 just hold nothing. I'll just have them be empty. So my array needs to be 13 numbers long. It has to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to create a 13 element array. I'm going to ignore the 0 and the 1. But the alternative is creating a 12 element array and always having to add 2 to my index. I don't want to do that. Okay, so I'll just create a 13 element array and just pretend that the 0 and 1 don't exist. I'm just not going to do anything to them. Okay, so I'm going to now ask the user, okay, how many times do you want me to roll two dice? Actually, I should probably have an explanation of what I'm going to do. Okay, I should type this out first. Okay, I will simulate rolling two 6-sided dice and keep track of the totals. Okay, do I have enough? Do I have an end there? I think I have an end there. Period. Enter the number of dice rolls you want. Okay? And then I'm just going to call that n. I read the next integer from the scanner. I store that in n. That's my number of rolls. And now I just need a loop to do those rolls. Okay, so 4. And I originally called it I, but let's call it something different. Let's call it for roll equals 1. We're not going to start numbering at 0. We're going to start numbering 1 less than or equal to n. I'm going to call it roll instead of I. Less than or equal to n. Roll plus plus. Okay. So roll 1, roll 2, roll 3, roll 4. There's no reason to start numbering your rolls at roll 0. I'm going to keep rolling the dice. Let me type my end bracket for this for loop. My end brace. End for loop. It's going to be a short loop. I probably don't need that, but I like to do that for clarity for you guys. Where's my... I lost my slash on my keyboard there for a second. Now I need to call my random number methods. What's that going to look like? Let's just call the two roles roll 1 and roll 2. So int roll 1 equals what? Equals my random object, my next int method. It's capital I. I make that mistake a lot. And then I want to generate a number from 1 to 6. So I generate a number from 0 to 5 and then add 1 to it. Okay. That'll give me a dice roll, a die roll. And then do it again. Roll 2 is equal to random.nextInt 6 plus 1. That'll give me another number from 0 to 6. And then I'll create an integer called total that is equal to the sum of roll 1 plus roll 2. Okay. I could print that out. I'm not gonna. I'm just gonna keep track of it all in the variables. But let's say I rolled 2 and a 5. That's a 7. I want to say, all right, in this array that I created called roll totals, I want the 7th element, the total of 7s, to go up by 1. So I want the element roll totals, element 7, or whatever I just rolled, element total, to go up by 1. Okay, let's parse what this line of code means. Whatever number I roll, I want that element of my array to go up by 1. So every time I roll a 6, element 6 goes up by 1. Every time I roll a 12, element 12 goes up by 1. Okay? Increment the value in the array corresponding to the total I just rolled. Total I just rolled. Okay? A little different than the array list where I would use get and set. I would use methods. This is actually much more like changing the value of an element in a list in Python. What makes these different from lists in Python? I mentioned this when we talked about ArrayLists, but didn't mention it just now. When I declare this array in Java, I declare it to be a certain size. It has 13 elements, and I cannot change the size of an array in Java. I can't just tack something onto the end of it like I could with a list in Python. Okay, so arrays in Java have a fixed size. They are immutable. But that's okay in this program because I know that my totals are going to go up 12, right? So I don't have to ever tack on a 13, 14, 15 to this array. So it's okay to use an array instead of an array list. Notice I also don't have to import anything to use an array. It's built into Java. I don't need a library or a package. Once I have that array, can I just print out that array at the end? I actually don't know. Can I actually just, when I'm done, say system.out.print? So that's the end of my for loop. That's the end of my program. What's the name of that array? Roll totals. Can I just do that? Let's see. I need a semicolon. Enter the number of dice rolls you want. Let's do 100. Ah! What is that? I at 14 AE5 A5. I guess that's telling us no, you can't just print out a whole array like that. It doesn't work. What do you have to do then? You just got to print out each element in the array. So I'm going to have to write another for loop. For, let's indent that. I'll just create a index that doesn't mean anything. I from, and I don't have to start at 0. I can start at 2, right? I less than or equal to 12. Okay, those are the elements in my, well, actually, less than or equal to 13. No, 12. 12. Okay, the last element in my array is element 12. 0, 1, we don't need to print those because there's nothing in there because we didn't roll any zeros or ones. We know that. You can't roll a 1 with 2 dice. So we're going to print out from element 2 to element 12. And then make I bigger every time. And then system out dot print line. I'm just going to copy that so I don't have to type it. What? The ith element of my array. So roll totals I. Close parentheses, end line with a semicolon, end for loop with a curly brace. Okay. So I'm going to count up from 2 to 12. I'm going to print out each element from 2 to 12 of my roll totals array. I'll add some prettifying of that output in a second. Let's just make sure it works. So I want 100 rolls. And there we go. There's the elements of my array one at a time. So it looks like you can't just print a whole array in Java, at least not the way I tried to do it. Maybe there's a better way to do it than what I'm doing right now. Okay. So this isn't very clearly labeled, but this is the number of 2s. So there are 4 2s, 7 3s, 12 4s, 4 5s, 17 6s, 20 7s, 14 8s, 8 9s, 6 10s, 7 11s, and 1 12. Let's make our output a little more user-friendly than that. So system print out number of space plus I plus letter S colon space plus roll totals. Okay, you see what that's going to do? Let's see if it worked. Let's do 200 now. 200. Okay, number of 2s, number of 3s, number of 4s, number of 5, number of 6s. So I'm printing out I and then the value stored in the array. What did I roll the most of? I rolled the most 7s, 35 7s. What did I roll the fewest of? 12s and 4 11s and only 5 2s. There's a pattern here. And if my number of rolls is big, and some of you may know this before, so some of you may have encountered this before and know this fact. Suppose I roll 1,000 dice. Okay, I get the most 7s, 173. The fewest 2s and 12s. Right? Suppose I do it 10,000 times. 1, 2, 3, 4. Oops, return. Return. Okay, the most 7s, 1,600 7s, only 1,300, 1,400 6s and 8s, only 200 2s, 280 2s, 282. Notice the number of 12s and the number of 2s is almost exactly the same. That's interesting. But if I roll dice a bunch of times and add them up, I get most 7s. people know this. Does everybody know why that is? I'm sure some of you know why that is. The reason is when you roll 2 dice and don't keep track of the numbers, just keep track of the total, there are more ways to get a 7 than there are to get anything else. There's only one way to get a 2. You can roll a 1 and a 1. There's only one way to get a 12. You can roll a 6 and a 6. There's 2 ways to get a 3. A 1 and a 2, or a 2 and a 1. There's a bunch of ways to get a 7, right? You can roll a 6 and a 1, or a 5 and a 2, or a 4 and a 3, or a 3 and a 4, or I lost track, a 4 and let's try that again. A 1, we'll start with the small number on first. A 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. Okay, so there are more ways to get a 7, so the 7 happens more often. In fact, the ratio, how many ways was that? That was 6 different ways, right? 6 different ways to roll a 7. 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So this number 1639 should be about 6 times bigger than 287. Is that true? What's 1639 divided by 287? Do I have a calculator around here somewhere? I guess I can just go to Google Calculator. 1639 divided by 1639 divided by 287. 1639 divided by 287 is 5.7, which is really, really close to 6. All right, so you get about 7 times as many 7s as you do 2s or 12s, because there's about 6 times as many ways to get a 7 as there are ways to get a 2 or a 12. And the more times I roll, the closer this ratio will get to 6. Let's do a really big. Will let us do 1,000,000? Will let us get away with 1,000,000? Let's roll 1,000,000 dice. One, two, three, four, five, 6 zeros. Really, really fast. Okay, so how many 7s did I get? 166,027. Oops. 166,027. How many, that was here. How many 2s did I get? 27,619. What's the ratio of those numbers? 6.011. And as I make this n bigger and bigger and bigger, that will get closer and closer and closer to a value of exactly 6. Which is weird, because this is random after all. How can we get so close to that ratio if the numbers are random? Couldn't we? Isn't it possible to roll 2 dice and get more 4s than 7s just from chance? Well, it's possible, but the more dice you roll, the less probable that becomes. The smaller and smaller that probability is. Those of you taking physics with me, we'll talk about this when we talk about entropy and heat flow, and it's actually related to some really important ideas in physics. The idea that there are more ways for certain results to occur than others. For our purposes, it's this interesting insight to the fact that random processes, if you have enough of them because of the laws of probability, can converge on an answer that is not random. If I roll more than 1,000 dice, I will almost never get more 4s than 7s or more 11s than 8s. It just doesn't happen. It would require such an improbable sequence of events for those totals to be flipped that it just doesn't happen. And if this number is very, very big, can I get to 10 million? 1, 2, 3, 4, 5, 6, 7. Okay, super fast. So how many 7s did I get? 1.6 million. Why am I getting tools when I do this? It must be the product. One of those must have been the product number of some Makita drill or something. Copy my 2s. how many 2's did I get? About 278,000. I divide those two numbers. I get 5.98. So very, very, very close to the ideal ratio of 6 to 1. 6 different ways to get a 7, one way to get a 2. And all the other, if you check the other ones, they'll all work out that way as well. We will next take a look at ways that we can harness randomness to actually solve problems in computer science with a method called a Monte Carlo simulation, where we simulate some result by just throwing random numbers at a mathematical function and taking a close look at what comes out. Okay. To follow up on this program, what I'll probably ask you to do is to do this again with a different number of dice instead of just 2, or with different kind of dice, 10-sided dice instead of 6-sided dice. So just like in the dice rolling assignment, I had you roll some number of different sided dice. You could do that for this and then keep track of all of the possible results that could occur. Now, if you change the number of dice, that changes the size of your array. So you couldn't do that dynamically. You couldn't do that after you had already created the array. So if I'm going to do a different number of dice or different kind of dice, I would have to ask the user for those numbers first and then create my array and make sure my array is the right size to hold those numbers, right? If I didn't, then I would either have to change the size of my array, which doesn't work. I'd have to use an ArrayList to do that. Or I will get an overflow error if I try to put numbers into the end of the array beyond the last element. If I tried to put something into element 15 of that array, I'll get an error because there is no element 15 of that array. So in the program I give you, you may have to read your numbers in and then define this size of this array with some variable that is different depending on what numbers the user enters. So that would be a good assignment to give as a follow-up to this. Okay, so that's all for this video.